In this video, we'll do examples to check the continuity of a function analytically. That is just by definition without using any graph. So the first example is given by f of x equals to x square plus 5x plus 2 divided by x square plus 5x. This is the given function and we have to check the continuity of this function at the point 2. Now to check the continuity, by definition we have to check two conditions. The first one is we have to check that the limit of this function exists at this point or not. That means limit f of x when x is approaching to the point 2. This point where we have to check the continuity. And the second condition is the value of the function must exist again at the point 2. If both of these conditions exist and are equal, then the function will be continuous at the point 2. So to do that, first we'll check the limit, that is limit f of x at the point 2. So first I'll put the value of the function, which is given by 2x square plus 5x plus 2 divided by x square plus 5x. Now to solve this limit, I can use the direct substitution method. So what do I get? 2 into 2 square plus 5 into 2 plus 2 divided by 2 square plus 5 into 2. So we get 8 plus 10 plus 2 divided by 4 plus 10, which is equal to 20 divided by 14. Now this means the limit of this function exists. Now we have to check the second condition. That means we have to find the value of the function at the point 2. Put this value in this function. So 2 square plus 5 into 2 plus 2 divided by 2 square plus 5 into 2, which is same as this. So if I solve this value, I'll get the same value, 10 divided by 7. Now both of these values are equal. That means the function is continuous. F is continuous at the point x is equal to 2. Now we'll do one more example, which is given by f of x equals to e raised to power 2x minus 1 divided by e raised to power x minus 1. We have to check the continuity of this function at the point 0. Now this is an exponential function. And to check the continuity of this function, we'll use same two conditions we did in the previous example. That is, we will find the limit of the function, and the second condition is we will find the value of the function itself at the point 0, where we have to check the continuity. So first I'll find the limit, that is limit of the function f of x when x is approaching to 0. Limit x approaches to 0, I'll just put the value of the function. That means e raised to power 2x minus 1 divided by e raised to power x minus 1. Now here, if I use the direct substitution method to solve this limit, I get 0 over 0 form. As you put 0 at the place of x, you get e raised to power 0, which is 1, and 1 minus 1 is 0. And in denominator also, e raised to power 0 minus 1, that is 1 minus 1, which is 0. So if I use the direct substitution method, it becomes 0 over 0 forms. That means the direct substitution method fails. So what I'll do, limit x approaches to 0, I will make the factors of numerator. So how I can write? E raised to power 2x minus 1 square e raised to power x minus 1. So limit x approaches to 0. Now e raised to power x minus 1 into e raised to power x plus 1 and divided by e raised to power x minus 1. I used the formula a square minus b square is equal to a minus b into a plus b to make these factors. Now here I can cancel these like terms. So what do I get? Limit x approaches to 0, e raised to power x plus 1. Now I can use the direct substitution method here. So what do I get? E raised to power x, that is e raised to power 0 plus 1, which is 1 plus 1, which is equal to 2. That means the limit of this function exists. Now I have to check f of 0. So f of 0, that means I have to put 0 at the place of x in this function. So e raised to power 0 minus 1, e raised to power 0 minus 1. Here you can write 2 into 0, which will be 0 only. So what do you get? E raised to power 0 minus 1. Again, this is 0 over 0. That means it's undefined. So for the continuity of a function, both of these conditions must exist and must be equal. But in this case, f of 0 does not exist. That means the given function f is not continuous at the point x equals to 0.